Let's take a look at a few more. Let's take a look at the absolute value of 12 minus 6x plus 3 is greater than or equal to 9 to at least start. So, first of all, we need to get the absolute value by itself. So we'll get rid of the plus 3 by subtracting 3 on both sides. What that then gets me is the absolute value of 12 minus 6x is now greater than or equal to 6. Now, once the absolute value is by itself like this, we can set up our two versions. Our positive version, which leaves the 12 minus 6x alone and leaves the greater than or equal to and 6 alone, so it's basically identical. That's your positive version. And then we can take a look at our negative version, which is still going to leave the 12 minus 6x from inside the absolute value the same, but we'll have a negative 6 and we'll switch the direction of the inequality on the negative version. So solving this, the first thing that we need to do starting on the first inequality is subtract 12 from both sides, which, let's see, gets us a negative 6x is greater than or equal to a negative 6. Beware here. We are about to solve this by dividing both sides by a negative 6. Remember, when you divide both sides of an inequality by a negative, it flips the direction of the inequality. So yes, our two negatives cancel out to leave us with just an x on the left-hand side, but our inequality is going to flip from being a greater than or equal to a less than or equal to because we multiplied both sides by a negative. On the right-hand side, same idea. Negative divided by negative is going to give us a positive. Well, 6 divided by 6 is going to give us a positive 1. Okay, getting there. Let's try the other part, the second inequality. We'll start by doing the same thing, subtracting 12 from both sides, which will give us, let's see, a negative 6x is less than or equal to negative 18. Again, we will divide both sides by a negative 6. However, we're dividing both sides of an inequality by a negative now, so again, the inequality is going to flip. We did this, though, so the 6's and the negatives will cancel out, leaving you with just the x on the left. However, your inequality is going to switch directions from a less than or equal to a greater than or equal to. Again, two negatives cancel out, and 18 divided by 6 is just a 3. So when I go to draw my number line on this guy, not always going to tell us to do this, but it always helps, is our positive version had the number 1. Our negative version had the number 3. Let's graph these two pieces. So we've got x is less than or equal to 1. That would be that we would be pointing to the left. Because of the equal to, we'd also have a bracket at 1. And how we would read this graph, because it comes first, is negative infinity to 1, where we have a bracket. The other piece, the second inequality, has x is greater than or equal to 3, which would be pointing to the right, and because of the equal to, would also have a bracket. That piece would be read as a bracket at 3 continuing on to infinity forever, which also has a parentheses, and unite these two pieces, we'd use the union symbol, and that would be our final answer. Continuing along for problem B. In problem B, let's see what we've got. We've got the absolute value of negative 5x plus 7 minus 4 is less than negative 6. Okay, for this one, again, we have an issue because we have this minus 4 that's dangling off to the side of our inequality here. So the first thing that we'd start off by doing is adding 4 to both sides to see how that can help us so we can have the absolute value by itself. This gives us the absolute value of negative 5x plus 7 is less than negative 2. Now, something should be sending kind of buzzers off in your head about this one, that this one looks funny. We always want our absolute value by itself on one side, and what kind of number on the other side? A positive, or at the smallest, 0. problem. We have a negative. Now, usually when people see negatives and absolute values, they jump to the conclusion that this means that there's no solution. Not necessarily the case when we have an inequality, so be careful. What I'm going to do is translate this into a sentence of sorts. Let's see. On the left-hand side, what we have is an absolute value here, which means on this left-hand side over here, we've got something that is most likely positive, but at the smallest it could be 0. And then we set a negative on the other side, and we have a less than symbol in the middle. So let's read this like a sentence from left to right. So from left to right, I'm saying I've got a 0 or a positive number is less than, and then on the other side we have a negative. So is something that's positive or 0 less than or smaller than a negative? Absolutely not. A positive or 0 is never smaller than or less than a negative. So what does this mean about the inequality? It means that this inequality is going to be never true. So this one does happen to be, because it's never true, it has no solutions. Or you can actually write it out a little bit fancier, which is with that 0 with the little line through it. It means there are no answers in which this inequality will ever be true. So this one does happen to be no solutions. Will they all be like this when you've got a negative on one side? No. I highly recommend we kind of turn it into a sentence that we can understand and kind of break up like we did here. So let's try a couple more. Here on this next one, we've got the absolute value of 4x plus 5 is greater than a negative 5. So again, what should be telling you that this is different is we have an absolute value by itself, and then we've got a negative on the other side, not a positive. So we've got a negative on the right-hand side. On the left-hand side, we have an absolute value, which again is either 0 or positive. And then we've got a symbol in the middle of greater than. So let's translate this into a sentence. So we are saying that something is positive or 0 is greater than or bigger than a negative. Well, this one's different. We've got something that's positive or 0 that we're saying is greater than a negative. That's always true. What this means is no matter what x value you choose, every one of them are going to work. So how do we write out an answer like that? And specifically, what they asked for was interval notation. What we're going to try and tell them is it's always true. I can pick any number I want. So what that'll look like for my final answer is negative infinity to positive infinity. And what that basically means is any number in any direction will work. Let's try another one. Let's take a look at the absolute value of 1/2 x minus 3 is less than negative 2. So again, we have an absolute value that's already by itself on the left-hand side, which is something that is usually positive or at the smallest 0. And then we have a less than symbol, and then we have a negative on the other side. So let's kind of translate this into a sentence again. So we've got something that's positive or 0 that we're saying is less than or smaller than what kind of value? A negative value. Well, a positive or 0 is never smaller than a negative. So this one's going to be back to our never true, which means that no answers will work. So our fancy answer is that there are no solutions. We'll use our little empty set. or you can write out no solutions, either or. In problem C, let's take a look. We have -2 absolute value of 3x minus 4 is less than 16. So the first thing that we notice is that this absolute value is not by itself. We have the problem of dealing with that -2 out in front. So the first thing that we need to do is get rid of the -2 so that the absolute value is by itself by dividing both sides by a -2. But there's a huge problem with doing that. Remember, when we multiply or divide both sides by a negative in an inequality, it's actually going to flip the direction the inequality is pointing. So instead of a less than, it's going to become a greater than. But at least now our absolute value of 3x minus 4 is now by itself. And on the other side, we just have a 16 divided by a -2, which is -8. So the question is, which one of these cases is this problem? So what we notice once again is that we have on the left-hand side an absolute value, which we know at the smallest is 0, but it's most likely positive, so we'll say positive or 0. And we have a greater than symbol, so we have something positive or 0 that's greater than, while on the other side we have -8, a negative. So let's read this out as a sentence. What this says is that something that is positive or 0 is greater than a negative. Well, remember that we know that something like that is going to be always true. Well, how do we write always true out in interval notation? Well, remember that's going to be our negative infinity to positive infinity, which means any value will make this a true statement. Okay, continuing along. Now this next